this parameter here, which is ID. Very often you'll see this type of thing on catalog websites, shoes, hats, any type of item. What we're going to do is terminate the original query with a tick and a semicolon, and then execute our own query here using XP command shell. So we're actually calling the extended stored procedure, and then we're going to execute a local command that's going to allow us to add a user to the domain. This is a native command called netuser. I'm simply calling it from the command line, which would be equivalent of sitting at a command console in Windows. And I'm adding my admin with a password to password /add to domain. And the important thing to note here is that it's going to create that user on the default domain of the service account, essentially. So you can't actually specify the domain if you have multiple domains in the environment, with this command anyways. And in addition to that, we'll kind of follow the same process here, terminate the initial query, call XP command shell. In this case, we're going to be calling netgroup, which allows us to add ourselves to different domain level groups, essentially. And we want to be a domain admin. We're very excited about it. We hear it's a wonderful thing, so we do it. We do /add my admin to domain, and bada bing, bada boom. We just created our own domain admin, which we can do whatever we want with. And, well, during pen tests, it's nice to have because people like to be able to see what you're doing, and we at least have some accountability, which in the real world you don't get. All right. So next up, attacking shared service accounts. So now, hopefully people have a general understanding at least of how the service account can be a threat with excessive privileges. This time we're going to talk about the repercussions of using a shared service account. Like I said before, it's typically one service account to run multiple databases. So it's kind of like one account to rule them all for any Lord of the Ring fans here, or having a skeleton key that can pretty much open any database. So for example, if you're using a shared database account, or service account, excuse me, to run all your databases in your environment, your low-value application administrator can access all the high-value application administrator's data. It's just inherited permissions. We're going to show you how that works here shortly. So the general idea is that we want to use unique service accounts every time so we can assign least privilege to each of them and that we don't have that line of inherited permissions. All right. So people have a hard trouble kind of grasping why this works, so I made this little abstract. Excuse me. Usually we'll come through, excuse me, let me maybe outline this here. We have an app layer, a database layer, a server layer. On the left side, we have all of the kind of low-value assets. On the right side, we have high-value assets, similar to the other diagrams. The attacker will typically come in via the low-value app. That application is communicating with the database with the app user, database user. That user is part of the sysadmin role, which is basically the database administrator account. And because we have that, we can execute those fun XP command shell commands. And in this case, we will be running it as a service account, which in most cases is also part of the local administrators group. And through the magic of Windows inherited permissions, we can execute commands on Windows Server 2 from Windows Server 1 with the account that's configured the same way. And now because this local account here is part of the local admins group, and that local admins group is part of the sysadmin role on MS SQL Database Server 2, which is the high-value asset, we can now get access to the high-value data, run the commands, cause general havoc, all that stuff. So let's go through this again. SQL injection, we know how that works. Excessive privileges on the database account, we know how that works. This time, though, we don't have to add ourselves to a group because we have this line of trust established between these two databases via the account. And so we're going to actually just use a tool called OSQL, which is another native tool. It comes shipped with MS SQL, I think, since version 7. Might be 2K. Anyways, we can leverage that with a couple cool switches that you'll see here shortly to wreak general havoc. All right, let's summarize that again. Once again, we see the SQL injection. Once again, we see we're able to execute local commands. And this time, though, the real problem here is that we're using shared service accounts instead of, some least privileged single service account. Let's take a look at the real-world attack. So up here first, we're going to do the same thing we saw before. We're going to terminate that initial query. We're going to execute our command shell. This time, we're going to run that command we talked about called OSQL. I would like to make one note. Sometimes you can execute it just by referencing it like that. Sometimes you need to put the full path. So look up your default paths. You can install Express or something on your box and you'll be able to go with no problem. And the output of this command is actually going to output to this live MS SQL server's text file. So what is it doing? That wonderful L switch there is actually going to take your database. Your database is going to send out a broadcast across this broadcast domain and say, hey, everybody, are any of you MS SQL databases that I might want to attack later? And they all very politely respond with, why, yes, I am. And so now we're going to pull that back in and write it to a file. So now we have a list of database targets. And for those of you who don't know what just happened, we just turned this backend database into a backend database scanner, all with native technology. Hooray for joy. Anyways, so once we now have this list, we're going to move on. We want to get some information from these. We want to test to see if they are, in fact, using shared service accounts with the same account we're using. So here, terminating the query once again, executing a local command. This time we're going to use a little, basically a command line script for Windows. So this is equivalent to something you would execute locally or in a command shell. And we're going to run through a loop. So for each of these servers, we're going to run this command that you see right here. And so once again, we have OS SQL. We're going to call for each of the servers, we're going to attempt to connect with a shared service account. And the reason we're able to do that is because of this magical -E switch. And what -E does, it inherits your current security contacts or your current privileges. And what that means is I don't need to know the password to the service account. Oh my God, I don't even need to know the username of the account. You can execute it completely blind. It's a wonderful, beautiful thing from an attacker perspective. Anyways, so next up, here we're going to actually try to email the list of databases to ourselves, because some people will write this to a table. They will then create an error or a union query that's actually going to spit it back out to the website so we can get that way. But in this case, we want to be more efficient and use one really quick line. And so we're going to use this SP send dbmail stored procedure, which is going to send the contents of our query to consultant.netspy.com. So once we do exec master command shell type database, it's going to echo the contents of our last command into that file and send it to us via email. And because, of course, I neglected the actual query in the last section, I'll touch on that. Basically, what we're doing here is we're going to echo the server name into the file, and after the server name, we're going to list all the databases, because we want to know which ones are sensitive. If the database says, hey, this is my credit card database, or this is our HR database, which they're usually aptly named, that's going to give us information for further targeting. So after we have this in email, we are going to clean up by deleting our files, and that's, once again, a pretty easy step. One thing before I hand it off to Antti here that I want to note is that here you're actually sending that data off in clear text. So there are a number of ways in SQL to do wrappers around to add some encryption, which you can decrypt on the other end. I really recommend doing it if you are doing a real pen test and not just kind of an in-lab scenario, because you don't want your company's secret data or your client's secret data spewing all over the internet or on everybody's mail server in 24 different places. All right, with that said, Antti.
Thank you, Scott. The next kind of trust that we'll be talking about is linked servers on MS SQL database servers. So what these linked servers are, on MS SQL you can create a database link to an external resource that you can then access through SQL queries. So you can create a link to another MS SQL database. You can create a link to Oracle database, MySQL database, Excel files, Access databases, text files. You can pretty much create a link to anything that you can then query. What these linked servers are used for, typically, if you don't want to replicate databases, you would create links to two databases so that you can access two databases from one. For replication, if you have really large data sets, you might not be able to replicate everything, so you just want to run some queries on another database. The problem here is that when we create a database link, we create one-way trust from the first database to the other database, or other resource, if it's a file or what, but we'll be talking about MS SQL database links to other MS SQL databases. So at the time when we create the database link, we set the permissions for that link. So I can say that let's create a link from this MS SQL database to that MS SQL database, and let's run all the queries with SA privileges or sysadmin privileges. So you create a trust relationship from the first database to the other database. The problem with that is that when we use SA or any sysadmin account, what we actually do is we're granting excessive privileges on that link. So even low privileged users can use that link to execute SQL queries on the other database server with escalated privileges. Other thing that we can do is a problem with linking. We can create huge database networks with these links. So we can say that the first database has 10 links to other databases. All those databases have 10 links to other databases. They can come back and so on. So you create a network of databases that trust each other. Best practice for that, of course, configure these linked servers to run with least privilege. If you only need to read some data from a database, don't give sysadmin privileges. Just give read access to that table or that database, whatever you need to have. Another thing about linked servers, just to touch quickly, linked servers, you run queries using Open Query. There's also Open Rosette, which some of you might be familiar with, which is another way to run SQL queries against another database. However, for Open Rosette, you run ad hoc queries. So what you can do, you can run queries without any prior work, so you don't have to like initialize the link beforehand. But however, you need to you need to have ad hoc queries permissions on the database server. And typically, if you're running as a low privileged user, you don't have the privileges to create ad hoc queries. The problem with the open query is that if a sysadmin creates a link from a database to another database and sets it up to run as SA or whatever, anyone who can execute any commands on that first database server can access that link. So you can't limit at least by default, you can't limit the access to that link for certain users. So even if it's created by a sysadmin, all the low privileged users can access that link as well. So again, we have the same scenario. SQL injection. We can execute SQL queries on LVA. However, this time the permissions are set up correctly on LVA. So we can read data, we can maybe write some data on the database server, but we can't really easily execute commands on LVA. So we kind of limit it to read access, maybe write access, but we don't have full control of the database server. What we can do here, though, we can select server name from master.sysservers table, which is a table in MS SQL that stores all the information about linked servers. So if you can do a SQL injection on LVA web application, we can query that sysservers table and get all the links on LVA. And in this scenario, for example, we see that from LVA there is a link to DB1. However, that link also is least privileged, so we don't really gain any further access on DB1. We can read from it, so we might gain access to sensitive information, but we don't have full control of that system. But because of link chaining, we can do a SQL injection on LVA that queries LVA database for links that are on DB1. So we can follow that path and find that we're not sysadmins on LVA, we're not sysadmins on DB1, but there's a link from DB1 to HVA database. And at that point, it's been configured with excessive privileges. And at that point, we can actually run commands on HVA database through the open query. So I have a few examples of the problems again first. SQL injection, of course. So if someone can do it, they can execute those queries. The other problem is that somewhere in the database link chain, there's one link that's configured with excessive privileges. Real injections, a little bit different format than earlier, but starting from the first one, we do a union select statement. So what this web application does, it returns one item from a table, so you can query one linked server at a time. So we create a union statement that selects server name from sysservers table. And because we can get only one value at a time, we have an outer top one and inner top one there in the select statements. when we increment the inner tab 1 to tab 2, tab 3, tab 4,